So standard form of a quadratic, y equal ax squared plus bx plus c. If you want to find the x value to your vertex, it's this formula. You guys know it. You did a ton of it last year. So if we're going to use if we're going to solve example 1, it's y equal 2x squared plus 8x plus 5. A is 2, b is positive 5, c is positive 5, right? A, b, c. All right, so now, so now let's find our vertex. Okay, you have to use that minus b over 2a. So minus b over 2. Okay, so b is 8, a is 2, and I get negative 2. So far I know my vertex is negative 2, and now I need to find my y component to the vertex. And that is just the function substitution. So take the negative 2, substitute it here, and if you're confident with the calculator, what you see is what you type. So 2, at any point if you want to grab a calculator, grab a calculator if you don't have one in front of you, right? 2x squared plus 8x plus 5, but in place of x, I plug in negative 5. If you can type it in, hit equal. I get negative 3. So far, so good? Easy, right? I'm recording. Whatever. Okay, what's my a value? Okay, 2, right? Is that 2 positive or negative? Positive, right? So does that mean, is it concave up or concave down?
Concave up.
Right, so it's going to look like this, which means my vertex is going to be that point. So is that vertex a max or a min point? Min, right? It'll be a minimum point. Right, and whatever the minimum point is, it's the same point as the vertex. It is that point. These are the same. It's just giving it a description. The vertex is a minimum point. Right? Okay. What's your axis of symmetry? It is always that dashed vertical line that is the h value to your vertex. It's the vertex, so it's negative 2. So this is not negative 2, it's x equal negative 2. Keep going? Okay. So if it's a minimum, if that vertex is a minimum point, what is the minimum value? Oh, I already gave it to you, sorry. So is it a max or min value? It's a minimum value, and that is always the y value of your vertex. Y value of your vertex. On the other one, I put k, but that's because it was vertex form. There's no hk here, so I know I put h, but it's the x value of your vertex, okay? But usually students kind of get what I'm saying. Okay, so it's the minimum value, so you just write negative 3, and this has to do with the range. We'll do domain and range for this one. Oh, and then our vertex was up there, but let's write it. Right? Okay, we got to do our table of values because we got to get a graph. So, graph. Okay. Your vertex, I always put it in the 3rd slot so that I can get the symmetry of top, top, bottom, bottom, right? So same thing, if you think of a number line and you think of negative 2, if I go, let's grab the scratch paper. Okay, so if this is negative 2, if I go 1 unit to the right, what's this number? Negative 1. If I go 1 to the right, it's right. So negative 1, negative 3. And then if I go 2 units to the right, what's this? And then 2 units to the right, right. So 0, negative 4. And so whichever one you want to put into the calculator, I didn't clear my calculator, so I can just go right in. I'm going to get 5, but 0, 0, and I get 5, negative 1, Okay, and I get -1. Yeah. Right? Just calculator. And now you plot it. So you guys, I went the wrong way. Go figure. Don't plot that. Yeah, don't. And I'm gonna put in my axis of symmetry right now. Better doesn't exist. And then your axis of symmetry, right? It's that dashed vertical line that cuts through your vertex, right? That allows symmetry to exist. Right? So that's why these points are symmetrical. Oh, touched it. Okay, we're going to do domain and range here. Domain. I'll pause to let you guys. Okay, on a parabola, so look, as you guys move along in your math classes, when you guys had lines, the domain was all reals, the range was all reals, right? We don't want to do anything, but when you guys are, when you guys then get to quadratics, it's now for the first time that you're given a restriction or a boundary, okay? So if you're a little like, a little confused on this, technically last year, this was the first time you guys got a restriction on range. Domain is still unchanged. Okay, do you guys remember what the domain was here? Do I have any restrictions on what value I can substitute x into the function? Do you guys remember? Do you know what your domain is? So, okay. Right, exactly. So look, I can plug a negative number into here, right? I can plug in -1. I can plug in -100. And I will get a number. It's going to be a big number, but I get a number. If I want to plug in +100, it's going to be huge. I get a number, right? I can plug in like 0.25. I can plug in a value that's close to 0, that's a fraction, and I get a number. I get a y value. I get an output value. So the domain is, okay, it depends how your teacher had you guys write it, but this is all of them. Okay, they either wrote all reals, if you remember that, or they did the double spine R. That means all real. Oh, sorry. That means all reals. It has like a double spine, kind of like that double spine D. Or they gave you -infinity to +infinity with parentheses, not brackets. It takes a lot of coordination to do that. That's what he's saying outside. Okay, let's see if it picks up on the video. Okay, what is your range? Okay, so look, my parabola starts here at the -3. There is no -4. There's no -5. There's no -10. There's no -100. The parabola is over here. It drops down to -3 on the y-axis, and then it shoots back up again. This, it doesn't exist past -3. That is your range. So when I tell you guys what's the max or min value, this minimum value or the max value, that number -3, it's either going to be -infinity to -3 or -3 to +infinity. And when we do them, you'll get more comfortable with it. But because it's a concave up parabola, -3 is your minimum value. So when you're writing the range and you have a left to right, it starts here, ends here. It's minimum, so it's on the left. And so it goes from bracket -3 to positive infinity, parentheses. So your range on a quadratic is that minimum or max value. Had it been concave down, it would have been -infinity to that value, whatever your vertex is. You guys get good with it, but that's why it is, because the parabola doesn't exist at -3.5, -4, -5, -10. It introduces at -3. It doesn't go anything lower. Okay. All right, it's kind of a long video, so I should probably cut it. There. Stop it? Yeah? Okay.